Hey guys, welcome to the fourth lesson on advanced C# programming. Today we're going to be talking about delegates, events, and Lambda expressions. We're going to talk about what delegates are, how do we use them, we're talking about events and how do delegates work with them, and then we'll talk about Lambda expressions and what are the benefits of Lambda expressions over anonymous methods and things like that. So let's get started. So the first question is, what is a delegate? And the most simple definition of this, which I really think, even though it's very simple, I really think that this helps people to understand what a delegate is. A delegate is simply an object that can hold a reference to a function, or it's some kind of object that points to a function, right? If we have a class and we instantiate and we have an object, we have an instance of a class, that object is pointing to other memory. All right, we have that picture, but it's pointing to a block of memory that object will use. Where a delegate is very similar to that, whereas a delegate is an object that points to a function, rather, just a function. So I could have an object that's pointing to, let's say, main, and if I use that delegate, it's going to be interacting with main. So I can invoke my delegate, and whatever my delegate is pointing to, it will execute that function and things like that. And we'll get into this, what I'm talking about. So yeah, the most basic definition of a delegate is that it's an object that can hold a reference or refer to a method. So when we go to set up our first delegate, there's a couple things we need to note about the actual syntax of it and what is the delegate doing and what does it require. So when we define a delegate, we're making a signature for it, and we're pretty much saying that any function that that has the same signature or has the same outline of this delegate is allowed to be used with this delegate. So that means that any method that agrees with the signature and the return types, the delegate can hold or point to. So when we go to define a delegate, we need to define the return type and the parameters of what all functions must have in order to work with this delegate. So let's go ahead and do this. And we're going to just mess around with some basic examples, and maybe we'll get into more complex ones as we go, because this video is probably going to be pretty long, just looking at how many things I need to go over. So let's just make a delegate. So the syntax for it is the delegate keyword, followed by the return type of the delegate. So we're going to say, in this case, we'll use void. Then the name of the delegate, so we'll say, I don't know, my del, this is just a test. And then it's the parameter, so I'm going to say it's going to take in a string. And yeah, that's it. Okay, so pretty much what we did by defining this is, we're saying that any function that wants to be used with this delegate must have a parameter list of one string and a return type of void. If any function matches this, then we can use it with our delegate. So now that we have our delegate, let's go ahead and make a function that works with our delegate. So we'll define it over here. And we're going to mark it static because main is static. So we're going to say static. The function requires a return type of void because that's what our delegate specifies right here. So then we'll name our function. We'll say test function. And then it has to have one string parameter. So text. We'll make this function that the text that comes into this, we're just going to display into the console. So we'll say console.writeLine text. So that's our test function. So now that we have that, now we can create our delegate. Because remember, a delegate points to a function. And now this function's signature and return type matches our delegates. So inside of main now, to create our delegate, we're going to say myDel, and we'll say del equals a new myDel. So we're allocating the new delegate. And as you can see inside the parameters, it's saying our target must be a function that has a return type of void and a string parameter, which test function does. So I can just pass test function right in like that. So now my del is pointing to test function. Now that it is, del, now that it is, now I can use del as if it is test function because it's pointing to it. So I can say del, and I can pass in, hello world. So now del, what's going to happen is this string hello world gets passed into my delegate, and my delegate is going to call all of its functions in its invocation list, which is only one function right now. I'll get into that more. So it will pass to test function, and then it will perform this function. So if we go ahead and run this code, now we see it says hello world. So once again, what's happening is we have our delegate, and our delegate is pointing to test function. Once we pass in, so because it's pointing, we can treat del as if it is the function. So I'm using del, and as you can see, when I do del and do that, the string, it actually says string s. So it's looking for a function with a string s, so that's where this works. So that's why I could pass in hello world. So, since version 2.0 of C#, there's a simpler way to actually create a delegate and assign things and do all that stuff. So it's called the method group conversion, and it allows us to, instead of calling this new mydel and all these things, if we leave it out and we just say mydel del equals test function like this, the compiler will automatically inject the call to new and all the necessary things. So we don't actually have to supply it. So this is just the shorthand, and this is what I'll use from now on. I'm not going to specify the new and the constructor and everything. I'm not going to explicitly invoke the delegates constructor. So I'm going to use the method group conversion. This syntax is just a simpler syntax for interacting with delegates. So another feature of delegates is this concept of multicasting. And multicasting allows us to pretty much create an invocation list, meaning that our delegate can point to not just one function, but rather it could point to many functions. And it has a list in its invocation list of what functions it should call and in what order. And we can build that invocation list with using familiar operators. You can use the plus, plus equal, and minus, minus equal to respectively add and remove functions from our invocation list. So for example, if I wanted to add test function in again, I could go del plus equal test function, and that will add that to my invocation list. So now delegate is pointing to two test functions. It's pointing to this twice, and you can see if I click these two references, you can see where that's happening. So now if I run it, as you would assume, we get hello world twice now. So we built in behind the scenes, our delegate has this invocation list, and we just added to it by using the plus equal. We can remove from it and etc. So I just added to my invocation list like that. One thing to note, that this is pretty important. If you have an invocation list, let's say it has 5 functions, if those functions have return types that are not void, meaning they return some kind of value, then what would happen in that situation? And what happens is, because if I call these and they all had return types, what return type would the whole delegate take? And what happens is, the value that is returned by the last method in the invocation list becomes the return type of the entire delegate. So whatever function is the last one will become the return type of everything. So I'll demonstrate this right now. So the first thing I'm going to do is I'm going to modify my delegate to return a string instead of void. And it's going to take in no parameters. Like that. So we're obviously we have to change this. So let's modify the first test function to do string and no parameter list. And all I'm going to do is, the first test function is going to return hello world. And let's make another function. And the second test function 2 is going to return, I don't know, by world. So test function says hello world and test function 2 says by world. So now if we start our delegate and we say my del test del equals test function, let's say we'll start out with that. Then we'll say test del plus equal test function 2. So now we're pointing to both of them. So they both have a return type. So if I say string result equals test del, like this, what is result gonna hold? Because both of them have return types, so which one will it actually use? So if I go ahead and display result, we'll get our answer. And as you can see, the return is by world, and that is because, like I said before, if you have an invocation list of return types, the last function that returns the value is the return type for the entire delegate. So that's how that works. Just on a quick note again, if you see, I just want you guys to really visually and mentally understand that if my delegate is different, let's say my delegate has a string parameter now, you'll see that all these things error because the functions that they're pointing to don't have string parameters. Watch, if I go like this and I say string s here, boom, test function will now go away. If I do the same thing here, now that error will go away. And the last one is because I'm not supplying a word. So I can do that. Now that will go away. So that just shows you that the delegate must match the functions that are being pointed to. So now we'll get errors again. But then the errors will go away if I change my delegate. So yeah, I just want you to really understand that a delegate points to a function, and B, the function that it's pointing to must match the delegate's requirements. Okay, so now that you understand that, now let's confuse you. So I just told you that the functions that the delegate points to must match the delegate's requirements exactly. But, however, that is not entirely all true, and I'm not going to go into this in too much detail, rather I'm just quickly explain it. So, there's two concepts called covariance and contravariance, and pretty much what they do is they bend the rules of the delegate requirements, and it's really only because the concepts of inheritance and how that works. So there's pretty much just two rules when we're using inheritance in delegates. So the first one is covariance. And covariance allows a method to be assigned to a delegate when the method's return type is a class that is derived from the class specified by the return type of the delegate. So I bet a bunch of you guys just went, what? So let me say that one more time and explain it. So covariance allows a method to be assigned to a delegate when the method's return type, so we're in this kind of situation, we're talking about this function, so when this method's return type is so string is our example right here, when that is a class that is derived from the delegate's return type. So if this I wonder, let me just try to show you an example real fast. Yeah, let me really quickly, I'm going to build two classes down here. Let's go class animal. No, I'm not going to give any definition. And then class dog, which is an animal. So these are two classes. So let's do the rule of covariance really quickly. So let's say this had a return type of animal. Let's take all this away. Just work with one function. Okay, so let's say our delegate had a return type of animal. Covariance, I'll read it one more time. Covariance allows a method to be assigned to a delegate when the method's return type is a class derived from the class specified by the return type of the delegate. So that means that allows us that since the return type of this delegate is animal, that means that the return type of a function that is pointing or getting pointed to by the delegate can be one that is derived from it. So if I put dog here, the error will go away. Obviously, that's erroring now. But as you can see, this error went away, and that's what we're talking about right here. So that's the rule. You can point to a function from a delegate if that function's return type is derived from the return type of the delegate. Okay, so hopefully you guys aren't too confused with this. So this is just, the main rule applies that they have to match completely, but this is inheritance. With the relationships of inheritance and that is a relationship allows these rules to be used. So that's the tricky part with that. But if you understand inheritance, you would understand this. So that's covariance. Now contravariance allows a method to be assigned to a delegate when the method's parameter type is a base class of the class specified by the delegates declaration. So this rule works like this. Let's say we had, let's make this void again. Let's say my del required a dog, D, let's say, for example. We could use test functions. Note this error right here. We can use test function if the parameter of this function is a base class of the parameter of the delegate. So if I say animal A, their error goes away. So as you can see, those are the two rules: covariance and contravariance. Covariance is working with the return types, and contravariance is working with the parameters. But yeah, if you ever came into a situation where you're working with these two things, do a quick Google search, and you don't have to remember this. I mean, it's not really just remember that there is covariance and contravariance out there somewhere. Now, before I continue on, let me really quickly say that this video is definitely for people. This is an advanced C# video. If you're learning C# for the first time and you went through the fundamental videos and you think you're ready for this, and this is an advanced video. This is really hard to understand if you are not at the right level, right? If you're trying to get at this too early of a programmer, you're gonna have a really hard time. So I just want to say that this is really advanced, and if you're not ready, if this is too hard for you to understand, go do other things, learn programming more, and come back, once you think you're ready. All right. So with that out of the way, let's quickly, before we move on to this concept of anonymous functions, why are delegates even here? I showed you and I explained a delegate points to a function. So a delegate is an object that holds a reference to a function. But why? Why would I ever want to use a delegate? Everything a delegate can do, I can kind of work around it, can't I? If I was learning it, that's what I would say. And there's two, pretty good reasons why we would use this. The first reason is that delegates completely interact and work with this concept of events, which we'll get to. We'll get to events. That's the last thing we'll talk about. So just on a side note, just remember that back in your head, and you'll see the importance of it then. But delegates and events work hand to hand. So that's one benefit of delegates. And the second benefit of delegates is that delegates give our programs a way to execute methods at runtime without having to know exactly what the methods are at compile time. So pretty much what that's saying is a delegate, because we can control the program with program flow control. At compile time, we don't necessarily know what function is going to be stored in that delegate. At runtime, we'll know, but that's the power of delegates, because it's a variable. Pretty much, it's a variable that's pointing to a function that can change. Right? We can add things to the invocation list. We can remove things. We can have just pointing at one thing. So at runtime, that's when we really know what functions we're pointing at, whereas at compile time, we don't know. Alright, so that's the basics of delegates. The next thing that we're going to start talking about is this concept of anonymous functions. Now, there are two types of anonymous functions that we'll get into. The first is anonymous methods, and then lambda expressions. I'll talk about them both, but mostly I'm going to spend most of the time on lambda expressions because lambda expressions were kind of created to replace anonymous methods, and they're more simplified, and it's a shorthand for anonymous methods, pretty much. But overall, the whole concept of anonymous functions, what are they? Okay, so there are going to be times, oftenly, that when you're working with delegates, you're going to be creating functions that are simply only used, and the only purpose of that function is to be used with the delegate, meaning that, that function will never be called on its own. You're never going to make an explicit call to that function. The sole purpose of of that function is to be used with the delegate. And when you have times like that, that is where we use anonymous functions. So anonymous functions are simply inline functions. They're pretty much functions on the go, I like to think of them. You pretty much, wherever you're going to be using the anonymous function is that you create the whole function right in that specific, instance. Wherever you're going to be using that anonymous function, it's created right there, and it could be inline. It could be within another function. And it's anonymous because there's no name attached to it. You don't associate the function with a name. An anonymous function has no name, and the point of that is the function is only used with whatever it's being used with right there, and that whatever is using it that can only use it, right? There's no name to it, so that we can't go back and make a call to it because it's anonymous. We don't know where it is. We don't know the name of it. Now, anonymous functions work well with delegates because delegates point to functions. And just because if you think about this logically, if you have an anonymous function, how are we going to keep track of that anonymous function? And a delegate points to functions, so pretty much my delegate's pointing to my function, and now I can follow that anonymous function and interact with that anonymous function through my delegate, because my delegate has access to it. Pretty much my delegate only knows where that anonymous function is. And yeah, so once again, an anonymous function, to sum it up, is a function that has no name. Really, the basic definition, it's a function with no name. So, like I said, there are two types of anonymous functions. The first one's anonymous methods, and the second one is lambda expressions. Anonymous methods, like I said, are kind of old, and no one really uses them besides like old legacy code. So, lambda expressions kind of replace that because it's easier and it's a shorthand for anonymous methods. But I'm going to show you one example of an anonymous method just so you can see what it looks like and what it used to look like. And it's good to know because, like I said, some legacy code still uses it. So if you saw it, you need to know what an anonymous method is. So we'll first do an anonymous method. So let's do that. Let me clean this up. We'll keep our delegates, but we'll just do that. So our delegate we're going to call count it, and our delegate count it. Our delegate is simply, I'm just going to make our delegate point to a function that counts from like 1 to 5 or something and display it to the console using anonymous methods. So, we'll first start off with building the explicit function. That whole function, we'll start with that. And then I'll show you how we can convert that into an anonymous method and then a lambda expression. So to start, let's build a function that works with this delegate. So static void test function. So that's our function. And like I said, all it's going to do is we'll do a simple like loop or something. I is less than 5, I plus plus, console.writeLine. We'll just do something like that. So it just displays some output. And then we'll make count it test del equals test function. It's pointing to our function. And then I'll call test del, and let's see the output. 0, 1, 2, 3, and 4. So that's our output that we want. Now let's do the same thing and convert it to an anonymous method. So we'll leave this here for reference. So we have our delegate, right? And we don't want to explicitly create it, like I said, because of all those rules before. If it's only going to be used with this delegate, why would we make an explicit function? We don't need that. So to do an anonymous method, it looks like this. Count it test del, and we need to point it to a function. So we're going to point it to an anonymous method. So it goes like this. You say delegate, you use the keyword delegate here. You create the body of the function, and then inside of it, this is what it looks like. This is annoying. Why is it? Okay. So this is what our delegate looks like now. So if we run this, actually wait, look, what's the problem? I didn't make a call to the function. So let's go test del down here. Now I'm calling my delegate, and let's see what happens. As you can see, the code gets executed. So what's happening is we're saying delegate. So this is the note that we're to the compiler that we're specifying an anonymous method in here. So inside of our body of our delegate, this is the body of the function. This is essentially, this right here is essentially this test function down here with no name. And that's the benefit of anonymous methods, right? It's inline, it's inside of this method. We built it, and it could only be used with this test del because the test del is pointing to it, and there's no name attached to it, so we can't call it. It's just called delegate, really. That's just a keyword. So this is our body of it, and then when we call our test del, that it uses the body of this anonymous method. All right, so really quickly, let's say, what if our delegate said, oh, my function now requires an integer. How do we work with this? So as you can see, we're getting an error. And the reason is because our delegate, our function, doesn't have a parameter of integer. So where do we add that parameter with anonymous methods? And it gets added right after the delegates. So I could say int x here. I'll just display x, whatever's passed in. So now that I have that, so this is where my parameters go for my function. So this is my anonymous method now. The parameter list goes here, and there's no name, obviously. And to execute this now, let's just pass in like 100 into test delegate, because our test delegate is using this delegate right here, so it says, oh, I need an integer. When I run it now, 100 gets passed into the anonymous method through the delegate's parameter list, like that. And the last thing with anonymous methods is, what if our function had, let's say, a return type of int? How do we interact with this now? And the same rule applies. So let's make our function add all these numbers together. Let's say int total equals 0. Total plus equal x. We won't display it, but then we'll just return our total. So it works just like another function does. The array goes away, and now I can say, int total equals, let's say overall total. And then now if I display that overall total, this is what I get, the 500, which is correct. So that's how we use return types, parameters, and everything with anonymous methods. So that's the basics of anonymous methods. The most important thing to really get out of this is, what are anonymous functions, and why do we use them? And we use them because of, when we want to interact with delegates and there's no reason to call it, we don't want a name for it, and things like that. We're pretty much creating functions on the fly. I like to think of it that way when I use them. You're creating a function on the fly just to be used for one sole purpose. So that's anonymous methods. So now we're going to switch to Lambda expressions, because Lambda expressions were created to I don't want to say replace anonymous methods, but Lambda expressions are shorthand for it, and they're just a little bit quicker and easier to use. All right, so what is a lambda expression? We pretty much went over it. A lambda expression is essentially it's an anonymous function. A lambda expression is an anonymous function. It's just handled a little bit differently than anonymous methods are. So to create a lambda expression, we use the lambda operator, which is the equal signs and then the greater sign. So that it makes kind of like an arrow, and we can refer to this as it logically saying, we can verbalize it as goes to or becomes. So it works the same exact way. So, let's first set up our delegate. So let's say we're creating a delegate, count it, test del equals, and then what does it equal? So this is where we put in anonymous methods. We could plug in an anonymous method, we could plug in a function, or we could plug in a lambda expression. So when we're working with lambda expressions, there's two types of lambda expressions that we should be familiar with. The first one is expression lambdas, and the second one is statement lambdas. Expression lambdas is pretty much when you have one statement inside of it. It's one expression. That's considered an expression lambda. A statement lambda is when you have a block, where you create that block of code, and then you have return statements and things like that, which we'll get to. So the first thing we're going to do is an expression lambda. So if we have our function, return type of int, and it takes in an int, how do we do this with lambda expressions? So there's a couple ways we could do this. The first way is I'm going to show you is by explicitly saying everything to make it more clear. This is the way I like to do it. So we're gonna create actually the first thing is on the left hand side of a lambda expression is the parameter list, and then the right hand side is the implementation or the body of it. So on the left hand side, we're gonna specify the parameters. So our first parameter is int x. That's it. Then it's our lambda operator, or goes to, and then this is going to be a statement lambda, expression lambda, so we're not going to have a body, it's just one statement. So what we're going to do is we're going to say, what should we do? We'll take whatever is passed in, add 5, and return it. So we'll say x plus 5, and that's it. So what happens here? Let's run it, and then I'll explain it. So, if I go int result equals test del, and I'll put in 5, then I'll display result and run it. What do we get? We get a 10. So what's going on here? So this right here, this is our expression lambda, or a lambda expression more generally. And what's happening is on the left-hand side of our lambda operator, this is our parameter list. So our function requires one parameter of int, so we specify that parameter in our lambda expression. We then have goes to, and then this is the expression part. We only have one statement inside of it. Now, our delegate has a return type of an integer, meaning our function must return an integer. So how do we do that? There's no return statement here. And that's because if we're working with expression lambdas, which is only one statement, by default, it automatically, if there's a return type required, it will return the value of that expression. So our expression is x plus 5, and it will automatically, by default, return that to make the delegate happy, because it needs that integer return type. So that's what it will do. It will do that return right there automatically. So that's how we're getting the 10. It gets 5 gets passed in. 5 plus 5 is 10, and then that gets returned into the result. And then we display result. So that's the most important thing to remember with expression lambdas, is that the return statement is inferred really because of the return type here. Now, talking about inferring things, the compiler can also infer other things, right? Because it inferred this return type of integer. well, then it can also return the infer the parameter because it has the delegate to go from. Count_int is a delegate which requires an integer parameter, so essentially we don't even have to specify that. We could just say x. Although I like to specify it because it makes it easier to read, you don't have to. I could remove these and say x goes to x plus 5. And this is really the beauty of Lambda expressions. It's so simple. Like this right here is an entire function call. If I were to remake that function, what would it look like? It would be static int, I don't know, my function here, int x, return x plus 5. So this entire thing right here is this one statement right here. So that's really the power of of Lambda expressions. That I can rewrite this entire function like this, all in this one line of code right there. These two are logically equivalent. That and that are logically equivalent. So yeah, but still, like I said, I like to actually specify my types just because, I don't know, it's still not that much code, but it makes it a lot easier to read. So that is an expression lambda. The next one, staying with lambda expressions, is statement lambdas. And statement lambdas are essentially the same thing. It's just it allows us to add more code into it. It allows us to have a body. We could add loops. We could add if statements. We could add anything we want. But then also, by adding those extra things, it removes the ability to infer the return type and infer the return statement. So then, in those kind of things, we have to explicitly write the return statement. So to make it into a statement lambda, we just simply add the body to our delegate. So why is this? Is this a return? Yeah. So it says not all code paths are return a value. So we need our return type now because it can't implicitly derive it. So in this, we could be like, well, all I gotta really do is return x plus 5. That's it. But yeah, so this is a statement lambda. Pretty much, it allows us to blow it up, and we can have multiple statements now by adding the block of code in. But like I said, by doing this, we lose the ability to infer the return type. So now we have to actually specify explicitly the return type with the return statement. But the benefit is we can do fun things. Like I can make a loop. So I can make a loop and do things in here like console.writeLine. I don't know, hi. So when I call it now, although I'll get my results, my function is displaying hi now. So we get that benefit of being able to call multiple statements if we use statement lambdas. But like I said, we lose that ability to infer things. We lose that ability to keep it as compact as possible. So the only time you're really going to be using statement lambdas is if you have multiple lines of code. If you're just doing this return, there's no point. I can convert this right back into my x plus 5 like that, and that's it. So that's expression lambdas and statement lambdas. So now that we got through all this, we got through delegates, we got through anonymous methods, we got through lambda expressions. These are all basics, right? We can go into a lot more details with all these things. Even though it's an advanced video, it's still a basic. I explain things in the basic way so everyone can understand it. And once you understand it, then you can take it to the next level and use it more advanced. The ultimate thing with understanding is understanding it in the most simplified form. And that's my biggest concern with most programming books is that when they're explaining complex new things to new beginners and people are learning new topics, they explain them, but then they go into detail like all the advanced things that you can do with it. That's good and bad at the same time. I think it's more important to understand something in the most simplified form. And then once you understand it, then you go to the next level. That's my philosophy. In all my videos, I follow this all the time. I always do it the most simplified way. Alright, so once again, we got through delegates, anonymous methods, lambda expressions, and now the bulk of it, why we're using all these things, comes down to this concept of events. What is an event? So, events. In the most simplified definition that I can really supply for an event is events are simply a programming notification system, just like our phones. Our smartphones have notification systems in it, and essentially, the events are essentially notification systems. An event allows us to, let's say, hypothetically, let's say we're building a class, and I implemented an event for some kind of action. Let's say we got a message, right? Let's say our class was dealing with messages, and our class got a message. If we supply and implement this concept of events, we can use this event to notify and make notifications to people who really care about them. So if there are other classes and other things interacting with this class that deals with messages, those classes can subscribe to my event, and if I get a message, I'll notify them. And then they can use that information with however they want to use it. So events are ways that we can notify other objects when a specific action has occurred. So that's simply, the basics way to, I think the easiest way to understand it, at least. Events allow us to notify other objects that some kind of action or event has occurred. So, the easiest way to see this is with examples. So, how should I do this? Okay, I'm going to make a class. I'm going to put it all in line, or in the same file, so it's just easier to read it and understand. And we can all see it at once. So I'm creating another class down here. I'm going to create a class called person. And my class person is going to have, let's see, it will have a private int, that's not realistic, a private int called cash. So our person has a wallet, essentially, and it has some cash in it. We're going to make a function, say void add cash, that adds cash to our wallet, essentially. So int amount, and it's simply just going to go cash plus equal amount. So our add cash function simply adds to our cash. Actually, let's make this a little bit more realistic. Actually, yeah, I'm gonna convert this into a property. So let's go public int cash. Hold on, let me make this real. This is just a property. Set. And I'm going to use the property here when I add cash, like that. Alright, so I have my private data, and then I created a public property. And I'm going to use this with my event system, and you'll see what I mean by that. So, my goal, what I want to do, I'm the developer of this program. I want to create an event that will notify people who care about this person when he, let's say, receives $100 or over $100. So once he hit that $100 amount or over, it doesn't matter, as long as at least 100, I'll notify everyone that, oh, this guy has $100. So that's my goal in this little program. So how do we set this up? Now what I'm about to show you is, I'm going to show you this version, and then as we get further into the lesson, I'm going to show you that there's other ways to accomplish this, and I'll show you the easier ways. But we're first going to start with the most basic type of how to do this. So the first step is we need a delegate because events work with delegates. We need a delegate because this is how it works. When someone is interested, let's say someone wants to know when he reaches $100. When that person's interested, they subscribe to my event. And when they subscribe to my event, they have to implement an event handler, and that event handler is what gets executed when I notify them. So when I say, okay, notify all my subscribers, all my subscribers' event handlers are what gets executed, and that when they get executed, that notifies them that the event was fired. That event handler that they implement must follow the guidelines of the delegate that the event uses. So now you can see that it's all coming together. So the first step is we need a delegate. So we're going to say delegate, and our event handler, what should our event handler do? We'll say void my event handler and no parameters. It's just a basic void no parameters delegate. Now that we have our delegate, now we need our event. Let's make this private. Now we need our event. So let's go public event. The syntax is public event, then our delegate that our subscribers' event handlers must use. So that's going to be my event handler. That's our delegate. And then our event. So we'll call it some event. Or actually we'll call it cache event. So we have our delegate and our event. Now that we have that, now we need to, before we implement the handler in our subscribers, we need to, when this action happens, when our cache is greater than 100, then we're going to notify our subscribers. So how do we do that? Well, we do that by, first we need to do a check, if our cache is greater than or equal to $100. So we have $100 or more, we're going to let our subscribers know. So we're going to notify our subscribers. How do we do that? The first thing we need to do is we need to call our event. If we call our event, that calls our delegate and calls all the event handlers that are subscribed and are in our delegates invocation list. So to do this, I first want to do this check. I'm going to say if cache event is not equal to null. And the reason why I'm checking that it's not equal to null is if there are no subscribers, meaning there's no one that wants to know when this event happens, then the event would be set to null. So by checking that it's not equal to null is I'm checking to make sure that there are some subscribers. So if there are any subscribers, then we'll fire the event. So we did our check. Now how do we fire the event? Now we're simply just do cache event and call it. This fires the event right here. So, okay, this is our function. Our add cache function makes our cache increase. If it goes over 100, it fires the event and lets all subscribers know. So this is our person class. Now inside of main, let's implement this. So let's first start off by saying person p equals new person. We got our person right there. So I'm this other person, and I want to be notified when this specific person, gains $100 or more. So to do this, I'm going to subscribe to his cache event. Do you see cache event with the little lightning bolt? So I want to subscribe to this cache event. So how do I do that? I go cache event, and now I want to subscribe to it, and I want to create my own event handler. So we're going to use the same multicast syntax that we saw with the delegates. We'll say plus equals, and as you can see, it's giving us a default. We can just hit tab twice, and that will create our event handler for us. We don't have to do this, but I'm going to do it anyway. It makes it easier. So I'll hit tab. And what we get is we get our function and our our function and what we're pointing to. So okay, let's just break this down a little bit so we can understand. So our delegate has a return type of void and no parameters, and that's attached to the event. So that's where we're getting this information from right here. Void, no parameters. This function was created because it has to work with the requirements of the delegate. So this function was created to work with the requirements of the delegate. And then our delegate essentially is we added this function right here to the invocation list of this delegate, which is this. Even though this is an event, behind the scenes we're using the delegate's power to hold references to functions. So right there, that's how we have the reference to this function. So inside of here, I'm just going to say, I don't know, console.writeLine, person has gained $100. Like that. So if I were to run this program right now, nothing would happen because the event wouldn't get fired because our person doesn't have $100. So let's start off by saying, okay, p dot add cash. Let's say $50. Run it. There's an error. What's the error? Oh, okay. All right, let's run it. We still have an error. What is the error? Oh, that's annoying. Okay, sorry about that. Okay, whatever. Okay, so where were we? So let's go ahead and run this. And as you can see, we don't get any output because he doesn't have $100 yet. If I do this again, however, so I added $50 and now I'm adding $50 again, that's $100. So essentially, we know that if it's $100, we're going to fire our event and let all our subscribers know. We're a subscriber. This is our subscriber right here. This makes us a subscriber. This line right here. So now our function that we subscribed with will be executed because it has $100. Let's run that. As you can see, the person has gained $100. So yeah, and that's how it works. So let's debug this and step through it so you can see what actually is happening. Where should we do this? I guess we really just look at this cache property. So let's run this. Okay, so the first time we get into cache, return cache, step, cache, okay, step it. Wait a second. Let's try this again. Let's go ahead. Let's put a breakpoint inside the set function. Because that's what okay, there we are. So this is the first time we're adding cache when we come in. And we do this check. So cache is now equal to $50. That's what we did the first call. Is cache is 50 greater than or equal to 100? No. So we don't ever enter in and let our subscribers know. Okay, so we come out. Add cache is called again. We come in. Yes. We get into our cache this time. Now look, cache is $100. Is 100 greater than or equal to 100? Yes, we step in. So if cache event is not equal to null, as you can see, I wonder if we can see this. Okay. I don't know. So, but overall, cache event is not equal to null. As you can see, it has some data inside of it. It's not equal to null, and that means that we have a subscriber. So, and I'll show you what happens if we don't. So, we have a subscriber, so let's notify them. So, we call cache event, and as you can see, my function right here is getting called because I subscribed with that function. So then that's where the statement gets executed. Let's run this again, but this time, let's not subscribe to the event. And what does it look like this time? So we come in the first time, It's not $50. So the second time, so now we're at $100 when we enter. When we enter it, so we get into here, and we do this check. If cash event is not equal to null. Look, cash event is null because there's no subscribers, as you can see. Because there's no subscribers, cash event is equal to null. Because we don't have that line of code. So that's the difference. If we have subscribers, then a cash event is not equal to null. So because it was null, we don't notify anyone, and we move on. With our life, nothing gets notified. There's no output. So this is the basic idea behind events. Events allow objects to notify other objects when a specific action has occurred. So in this case, we want to build a program that if their cash goes over $100, we want to notify all the subscribers. You subscribe by adding your function to the invocation list of the delegate supplied in the event. We do that by creating a function that meets the requirements of the delegate, and then we just add it by using the multicast syntax to the cache event. And that allows us to subscribe to it. So when the class says, okay, notify all my subscribers, this is what happens. Okay, so yeah, that's the basics with events. Now, the same rules apply with delegates, right? There could be multiple people who want to subscribe for this event also. So I could have another function subscribe to this same exact event of this same exact instance. So you can use multicasting and do a bunch of different calls. So you can have as many people as you want subscribe to this event. Okay, now there's also another thing we started talking about. We talked about anonymous methods and Lambda expressions. Those obviously still work with this because our delegate is still behind the scenes in this event. So we can use all the same things with that. So let's say if I wanted to change this around, instead of actually making this explicit function, let's say I had cache event plus equal, and what was our delegate? Our delegate is void return type, no parameters. So how do we do that? No parameter. I guess the best way to do that is going like this. So we're saying no parameters goes to, this is our Lambda expression, and we're just going to do console.writeLine person has $100. So does this Lambda expression match our events delegate? Does it? So we have no parameters, no parameters, and no return type. There's nothing. Yeah, this has a return type of void, right? Yeah, nothing is being returned, so we match the return type of void also. So this is our Lambda expression. We could do this as well if we run it. We still get the person has $100. The same thing happens. We come in. Actually, I'll show you this real quickly. If you didn't know about the debugger, there's some cool things we could do with this. I'm going to change the hit count to break when hit count is equal to 2. So if it's the second time being int, I don't want to do the first one anymore. So if I run this now, when we enter it, we have cash is equal to, let's just go to the next line. Cash is equal to $100. This is the second time we got into it. So when the cache event is called, now it goes, look, it jumps to the function that's subscribed to the subscribed to the event. This is our event handler, and it jumps to the Lambda expression, execute that line of code. So the same thing happens here. The same thing happens, except we're using Lambda expressions. So just note, events can use anonymous methods, Lambda expressions, and you can use its own functions, and that thing that you're pointing it to is the event handler. So the last thing I'm going to be talking about in this lesson, let me check. Right? Actually, there's really like two things, kind of similar. The first thing is guidelines. .NET event guidelines. Now, these guidelines do not have to be followed, right? Because, the things that you do are for yourself, but .NET follows these guidelines, and I'll show you how that they even follow them. And they follow them because they were trying to make a standard. They were trying to make a standard for their languages. But you don't have to follow it. But the guidelines with events are pretty basic. And I'll show you how they work. The first guideline is, the main guideline is that all events, or essentially the delegates or event handlers, must have 2 parameters. Every single one must have 2 parameters. That's what they want. The first parameter should be a reference to the object that generated the event. So in this case, the first parameter in my event handler should be a reference from this person, saying that a person is the one, or this person more specifically, is the one that called the event. And I'll show you how we can follow the standards here in a second. The second standard, or the parameter, is that the second parameter should be of type event args, and that should contain any information that should be passed forward, should be contained inside of event args. Now, the actual event args class isn't used that way. We're instructed to create our own event or our own event arguments that derives from event args, and that can have some information. The details aren't that important with this, rather than just knowing that these are the guidelines that they follow. So I guess I'm going to show you that the first thing I want to show you is the guidelines that they follow, and to actually show you that they actually do follow them. So I'm going to create a new project. Actually, let's go File, New Project. I'm going to create a Windows Form Application project, and I'm going to put it onto my desktop. I'm just going to call it whatever, hit OK. So what I want to show you that is that their events, they follow the same guidelines for their events. So if I go ahead and put on a button. Now, if you don't know this, don't worry. I just want to show you. This is a button, and as you can see, there's this lightning bolt, which stands for events. Buttons have all these events, and they work the same way that how we just used them before. If I double click on it, that will create an event handler for the. So it created an event handler for the button being clicked, and as you can see, the standards that .NET placed for the event guidelines is being used here. We have the object sender and the event arg. So the standard once again was that the first parameter be a reference to an object that generated the event. So whatever generated the event, that's what refers to it here. And the second is the event args, which contains any information that it should be needed by the event handlers or the subscribers. In this case, I'm the subscriber of this button click. I subscribe to their button click, and I am. Yeah, I wonder if we can get to the code behind. Let's see. If I go to definition here, is it here? Oh, there it is. Look at this. So this is cool stuff for behind the scenes. This is kind of like the behind the scenes. This is the Form 1 designer class, and this is what is actually I don't know if this is actually calling it, but you can see that this syntax right here, this is where we're actually registering for or subscribing. This is our subscription right here, and we're subscribing to the click event right here. As you can see, if I go this button 1 click is that lightning bolt, and when we created our own function, our own delegates, we got that same lightning bolt effect. So they're using the same things, but they're just using built-in kind of delegates, which I'll get to in a second. So yeah, so click, and then they subscribe to it by saying, okay, we're subscribing to, this is our event, our delegate event handler, which we'll get to in a second, and we're passing in this function as our event handler, this button one click. As you can see, button one click, or button one underscore click, is right here, and these are the guideline parameters. So the event handler, now .NET also supplies us a generic and a non-generic, which I didn't teach generics yet, so I can't really go into detail with this yet, but they supply a generic and non-generic event handler that follows the guidelines of their guidelines for events. So as you can see, this, I'm subscribing to this event, and I'm using the event handler, delegate. And if I right click and hit peak definition, which is a new feature of Visual Studio 2013, it allows me to see that the event handler delegate is defined to follow the standards. Also, an object sender and event args e. Now, they're doing it this way. Remember, there's all different syntaxes with doing this. I could simply, let's see if I can modify this. Let's see. Let's have some fun. If I take this out. Yeah, okay, let's try to run that. Hold on, let me put in a message. As you can see, it still works, right? So there's all different forms to events, right? I showed you a few of them. Like, you don't have to supply the delegate. You don't have to say new. You can just infer by using the method group conversion. You can it will infer and automatically inject the call to new if I just pass in a function. I could also, what else could I do here? If I didn't want to say, oh, this button dot click, this dot button one click, if I didn't want to pass in the function, what else could I do here? I could do a Lambda expression. But my Lambda expression would have to follow the guidelines because the event requires that. How would I do this? If I go, let's say, object and event args e, if I went like that, goes to just system.windows.forms.messagebox. But I'll do TT like that. Let's try that. What happens now? As you can see, a TT with that Lambda expression works. So this is just a little off the side kind of thing. This represents the object O, and this represents the event handler. I don't know where it is. System. Okay. So yeah, that's where that happens. Why is it erroring? Oh, this is not event handler. This is event args. Sorry. Alright, so yeah, so this is just a little rant. You don't have to, and it's not important. This is a little kind of cool thing behind the scenes, how it works, etc. But yeah, so event handler, just like I said, event handler is a delegate that's already made for us that follows the guidelines, follows the guidelines of .NET. So if you want, you don't have to create your own delegates. You can just use the basic generic or non-generic event handler delegate that's already made for us. Whatever one makes you happy. Okay, but that's it for this lesson. So we went over delegates, anonymous methods, Lambda expressions, events, and then we talked about a little bit of the .NET standards and this generic and non-generic built-in delegate called event args, which follows the .NET guidelines. So yeah, that's it for this lesson. I hope you guys enjoyed it. If you have any questions, be sure to leave a comment. And if whatever you want to see next, you could also leave a comment with that. And I'll think about it. I don't know what I'm doing next for this series of videos. I'm not sure yet, but yeah. Anyway, thanks for watching.